All right, so just to recap, if you missed it earlier, okay, what we're going to do is if we have f of 3, then that's saying take 3 and plug it in for x, right? So when we plug that in, we get 5 minus 0.2 times 3, and y'all told me that was 4.4. Now you're going to ask yourself, is 4.4 greater than 0? Y'all told me yes, so we're going to circle. On this next one, we got 4.4. Is that greater than 0? Or, I'm sorry, greater than 5? No. Okay, on the next one, when we plug in -1 into this equation, we would get 0.2 times -1 plus 5. So this would give me 0.2 times 4. And 0.2 times 4 is what? 0.8. So is this a true statement? Yes. On the next one, we've got 0.8, which is g of -1, is less than f of -1. So we need to go in here. We need to plug that in. So 5 minus 0.2 times -1. So this is going to give me 5 plus 0.2, which is just 5.2. Is this a true statement? Is 0.8 less than 5.2?
Yeah. No. Yeah.
0.8, is it less than 5.2? Yeah. So true statement. On that last one, we have f of 0. So we're going to plug in 0. And when we do that, we're going to get 5, right? When we plug in 0 into g, we're going to get 0.2 times 5. What's 0.2 times 5?
2.
Yep.
1.
1? Okay. Is 5 the same thing as 1? No. This would be a fair question for them to ask on your interim. This would be a fair question to ask on your SAT. Okay. You've got to know function notation. It does not go away. You will use this throughout your math career. Okay. All right. So today we're going to keep talking about interpreting domain and range. Okay. In context. And we're going to talk about our input and output. Okay. Okay. So you should have gotten the other documents, domain and context, linear function. So it looks like this. Okay. All right. So I'm going to give you a set of cards that contain a number. Decide which each number, if it's a possible input or a possible impossible input. Sort the cards into 2 groups and possible inputs and output. Record your sorting decision. Okay, so I'm going to give you some cards in just a second. On your other paper with the note. Okay, what did you get for the possible inputs for these? We already got 6.8. What else? 9 works. So if we plug 9 into here, will we get an answer? Yeah. What else? 0.8. So we plugged in 0.8. We would get something in here. Cool. Anything else? 4. If we plugged in 4, what would we would get 250? Good. Was there anything that didn't work? 72 did not work. 15 didn't work. Notice how those are all the way over here, right? On my graph. Okay. Was there any other impossible inputs? Yep. -3. -18. Anything else? Okay. So what would be the domain of this function? Well, what's our farthest left x value? 0. And then what's our farthest right x value? So our domain would be from 0 to 14. See how we did that? Okay, on the next one, we're talking about converting from Celsius to Kelvin, and that actually is the equation for it. What is the coldest temperature in the world? What is it called?
-145, I think.
Okay, so what is that called? There's a term for it. Absolute zero. Absolute zero. That was close. Okay. So absolute zero is like the coldest thing that you could possibly get. We really can't get there unless you're like in Antarctica when it's like nighttime. Like, yeah. Right. In the pool, in the water. Like, you know what I'm saying? Like, it's negative. Like for us, when we talk about temperature, it can be 0 degrees Fahrenheit here. Like it could be, right? That's cold for us, but it's not the coldest that it could ever get. When we talk about absolute zero, it's like in the negatives. Yeah, that's not nice, especially if there's a wind. Not nice. So what values could I have plugged in for this one? Everything, right? I could have plugged in any number and I would have gotten an outcome, right? So all numbers. Oh, is there anything that didn't work? No. So when we say that for the domain, when we put that into math terms, when we say that all numbers can be plugged in, that means that the domain is going to be from negative infinity to positive infinity. Really quick, what type of function is this guy? Linear. And we know that the domain of a linear function that doesn't have any restrictions on it is going to be negative infinity to positive infinity, right? On the last one, it was linear too, but it had some restrictions because it only had a 350 maximum. Okay, so most people didn't get to this last one. So let's kind of think through this together. We got a tennis camp that charges $40 per student for a full day camp. The camp runs only if at least 5 students sign up, right, guys? And if it limits the enrollment to 16 campers a day. The amount of revenue in dollars that the tennis camp collects is a function of the number of students that enroll. Okay, so here's my little equation, right? Okay, what are possible inputs that I could plug in? So they said I have to have at least 5 students, right? So could I have any X values that are less than 5? No, so what X values are less than 5 that you have? 0, 4, -3, what else? Maybe 0.8, I think is on there. Is 6.8 less than 5? No. However, can we have half a person? No, so 6.8, 6.8 doesn't work. These are the ones that don't work. I'm so sorry. Let me fix that. I apologize. I'm so sorry. Sorry. I was making a list. Okay, anything else that doesn't work? Any negative numbers? Any numbers that are bigger than maybe 16? -18. Anything else? Okay, so that's it. Okay, so then our other possible inputs would have been like, I don't know what numbers you have. Would 72 have worked? No, that's too big, right? Because they can only have up to 16 campers, right? Is 9 in between 5 and 16? Yeah. Okay. What else? 15 works. What else? Any other numbers that you have that are between 5 and 16? Okay, so this is important. Ready? How you write the domain for this one is our farthest left X value was 5. Our farthest right X value was 16. They tell us up here at the top where they can only have 16 campers, but they have to have at least 5. So our domain is going to be from 5 to 16, where X has to be a whole number or a real number. Okay? Because we can't have half a person. If we just said from 5 to 16, that includes all your decimals as well. Okay? now. So output is our range. Okay, this is on the note sheet. Okay, so the set of all possible output values is called the range. So here's the graph that represents this, where M is the missing number of minutes a tank is draining. Okay, so really quick, where M is the minutes, and this represents the tank draining. Okay, I want you to name 3 pairs of input output. I'll give you the first one. Let's say 8, 150. That's an input output. What's another one on here? 7 what? 100. 10, 100. Good. 10, 100. Anything else? 2, 350. 2, 300. That's okay. All right. Does everybody see where I get that from? An input-output pair is just a coordinate pair, right? That's what we know as we call points. Okay. Earlier, we described the set of all possible input values for function g, the domain as 0 to 14. So the domain was from 0 to 14, right? How would you describe the set of all possible output values, the range? So what's my lowest y value? Okay, and what's my highest y value? 350. So from 0 to 350. Okay, I need us to get domain and range really quick. When I do domain, you see how I'm using these little bars? Okay, domain is left and right, right? So watch how I do this. Domain is from here, because that's how far to the left it goes, to the right side. That's how far right it goes. So what numbers are those? 0 to 14. If I'm doing range, I'll do a different color. I go from my lowest y value to my highest y value. So what is that in between? 0 and 350. You gotta know this. This does not go away. Okay? Are there any questions about this? I need you to know domain and range. Like, be the class that understands domain and range. Okay? Sorry, I feel some type of way about it. Okay, the set of all possible output values is called the range. Okay, here's this function. Is 20 a possible output? Okay, so for output, is that range or is that domain? That's range. So we're looking at, are we looking at X or Y for 20? Y. So is 20 a possible output in this situation? So if we looked at our graph, is there a spot where there would be a 20 for the Y value? And if you are unsure, what you can do is go into Desmos, graph your equation, and then we want when Y equals 20, right? We're going to zoom out. And do they cross over? Yeah. But let's make sure that that makes sense in context. So we got 0.5 comma 20. So would it make sense for us to have 0.5 of a student? No. Okay, so would 20 be a reasonable output? No, 20 would not, because you can't have 0.5 of a student. So you can't have 0.5 of a student. What about a 100? So again, if we're not sure, we can go into our graph and look at when Y equals 100. Where does it cross on the graph? 2.5. Can you have 2.5 of a student? Okay, so that one doesn't work either. Hey, how are you? Can't have 2.5 as a student, right? We can't have 2.5 students. So 100 would not work. Here are the two graphs that relate the number of students and camp revenue. Explain why graph A could not represent the function. Okay, so here are the two graphs that relate the number of students and camp revenue. Explain why graph A could not represent the function. Go ahead. Okay. So let me ask you this question. Right here, that's in between 0 and 1, right? Can we have half a student? No. What is this graph doing? It's going only on the whole numbers, right? We can't have half a student, so we would have to only have the whole numbers. Okay, so graph B has to be the graph because we can't have decimals as a student. So when we graph this, we don't want to make it like a continuous line because that's including those decimal points. Okay, I don't see a whole lot of people writing it down, and I just wrote down a sentence. Put it on your paper. Okay, so what is the range of function R? Okay, so since we can only have whole numbers as students, looking on here, graph B would be our graph, right? What's our lowest Y value for graph B? 200. What's our highest Y value for graph B? Okay, so we're gonna go from 200 to 650. Everybody see how I did that? So a small bus charges $3.50 per person for a ride from a train station to a concert. The bus will run if at least 3 people take it, and it can't fit more than 10 people. So how many people could we have? 10 people max, but how much could we start with? What's the least amount? 3. So for our domain, we're gonna have from 3 to 10. See how that works? If I took 3 people and I charged them each $3.50, how much money would I have? Okay, so 3 times 350, y'all are telling me at $10. Okay, so there's my point right there. Now, if I put 10 into this, how much is that gonna be? 10? Yep, if I put 10 in, I'm sorry, if I multiply 10 times 350, it's 35. I'm gonna have 10 and then 35. You see how I got those 2 points? Okay. So you're telling me that my range is from 10 to 35. Oh, y'all said it was 10.5, my bad. So it's up here. Now, could I have 4 people? Yeah, okay, so 4 times 350 is going to give me 14. So I would graph that right here. Could I have 5 people? Could I have 6 people? Could I have 7 people? Could I have 8 people? Could I have 9 people? And then I can have 10 people. Can I have 11? No, that's too many, right? So this is how I would go about graphing it and writing the domain and the range. Okay, again, I need us to be good at this. At least the domain and range. You don't have to be perfect at sketching, but domain and range. So for the first one, the domain of the function is from 0 to 170. Is that true or false? True. Okay, remember our domain is left to right. Okay, and that's from 0 to 170. The next one, I know this notation is really weird. They like to change it up on you. But this is the same thing as saying from 150 to 170. Okay, so is there an interval of decrease from 150 to 170? Is that right here? Yeah, so that's decreasing, that's true. Is the only x-intercept of this function at 170 comma 0? Does it touch anywhere else on the x-axis? False. Why? It touches 0, 0. Okay. That next one, I know that notation's a little funky, but this is saying the range is from 0 to 50. Okay, notice how I use brackets on this one because there's a line underneath that inequality. Okay, so is the range from 0 to 50? Why? Because it touches 60, right? So it goes past that 50 mark, right? So this is going to be false because it goes higher than 60. Or I'm sorry, it's higher than 50. And this one was, there was an x-intercept at 0, 0. Okay, the last two. There are two intervals of increase. So looking at our little graph, we got an increase right here. We got an increase right here. So that's true so far. One is from 0 to 20, which is right. And the other one is from 40 to 60. Is that correct? Is it from 40 to 60? No. So that's going to be false. It's the wrong interval. Now, were there two times where the boat did not move? Okay, so it just was constant, right? It stayed in the same spot, so that's true.